In the last video, we answered this question. Given the following hypotheses, find the probability of detecting a true population proportion of 0.380, supposing all conditions are met. And in that case, the sample size was 250. Well, let's change that to 500. Let's increase our sample size. Now, when n was 250, the power was 0.102. So let's just kind of keep that little note there and see what happens when we increase the sample size. Okay, so the first step is to find these critical values, or these z-values, which we already know what that's going to be. If we have 0.025 in each tail, that will be 1.96 and minus 1.96. And we would use the formula z equal to p hat minus p0 divided by the square root of p0 times 1 minus p0 over n, and then rearrange it so that we had p hat equal to z times the square root of p0 times 1 minus p0 over n plus p0. And we would find a left-hand value of 0.318 and a right-hand value of 0.402. Now, how does that change the result? Well, this value then, this right-hand value is 0.402, and this left-hand value is 0.318. Now let's project all this to a distribution where the population proportion is 0.380. We'll call that P1. We have our hypothesized proportion, but if our actual proportion is 0.380, then we'll give it its own little subscript here, a 1. And if our sample size remains the same, then our distribution should remain the same in every regard except a shift to the right. So now this 0.402 projects here, much closer to the population proportion than it was here when the hypothesized population proportion was 0.360. And then 0.318 lands farther out here to the right with less area out here in the tail. So we have 0.402 here and 0.318 here. Now let's find z-values associated with those two values. So we'll have a right-hand z-value and a left-hand z-value. We'll calculate those values again using this same formula. So our right-hand z-value will be 0.402 minus 0.380 this time, divided by the square root of 0.380, since what we're working with is this distribution now, times 0.62 over 500. And that z-value will turn out to be 1.01. Then, doing the same thing for our left-hand z-value, we'd have 0.318 minus 0.380 divided by the square root of 0.38 times 0.62 divided by 500. And we'll wind up with minus 2.86. So we have 1.01 and minus 2.86. Now, if we look those up in a table or use a utility like the TI-83 or 84 calculator or StatCrunch or something similar, what we'll find is an area here of 0.156 and an area here of 0.002. So the power will be the sum of those two values, 0.156 plus 0.002. So this turns out to be 0.158. Now, what happened when the sample size increased? Everything else stayed the same. The power increased. So when the sample size is increased, the power increases. And we should specify all else remaining the same.